Conference will now be recorded.
And I'll just say this too, if you're able to, go ahead and turn your cameras on if possible. Hey, I should have just waited like 2 more seconds. Hello, Daniel. Welcome. All right, the recording has started, so we'll go ahead and start today. We'll be talking about full stack specifically. When you hear the term full stack, so NodeDB was 3/4 stack. You've heard that term. When we talk about full stack, we hear that, we see that a lot on the internet as developers. When we talk about skill sets, we talk about full stack. Just free conversation here. Anyone speak up? 1 or 2 answers. What does full stack mean to you? And if you don't typically speak up to, I encourage you.
Full stack to me means that we take a layer that the user interacts with and we hook it up to a server that is an interface to our data that defines our rules and our functionality with that data. And then we also add another layer on that is our data, basically your database or whatever, and all of the operations that you do on that. And that's what full stack means to me.
Thank you. Anyone else? What does full stack mean to you? Whether it be like a definition of it or how you think it would be helpful to know.
So for years, I've heard of the mean stack and the merge stack, and I believe those are full stack with the database and front end, back end, with React inside and Express. Yes.
Yep. Cool. And Daniel, did you have something?
No. I'm good.
Okay. Dig the style today, man.
Thank you. Just trying to stay cozy,
For sure. So when I'm talking about full stack, just to get to like the basics of it, I'm referring mainly to something, the stack that includes like the front end technology. So what have we been using for front end? Just shout it out.
React.
So React is what we've been using on the front end. Back end technology, what we've been using on the back end.
Node.js.
And Express.
Yep. So Express for the server. So front end, back end, server, and databases are missing link here. So we'll talk about the database today. And specifically, it is good to be excited about this. So this is the missing part of the missing link today. Of course, I have the full stack in there. So we use React. Well, we've used React, Node.js, and Express. We haven't talked about the database much. We've alluded to a lot of it. We've simulated databases in our NodeDB by having things saved on the server itself. And today we'll be using database technology called PostgreSQL. Raise of hands, anyone that's heard of Postgres?
I was required to take it as part of an attempt to graduate college.
I feel like you worded that very carefully.
I did.
Required attempt. I'm going to see if I can do a screen share here real quick.
Actually, they made me take Microsoft version of SQL, and I wanted to learn PostgreSQL instead, but option.
Got you. So, and we'll talk about that too. But Postgres is a flavor of SQL. PostgreSQL, the SQL comes from SQL being a flavor. Good news is, if you learn one flavor, you can pick up on another flavor of SQL quite easily. Let's see. Oh, that's not giving me an option. All right, I was going to try out this little digital pad thing, but it's not going to work. So I'm going to pull up Paintbrush. All right, good old reliable paint. There we go. All right, so get ready for a crude drawing here. So what we've talked about thus far, where's my mouse? Just to give a visual of this, that perfect square showing up. All right, so we have our front end. Here we've been using React. I can get around that. Hey, I just wrote that by hand, by the way. So we've been using React. We've been dealing with this. So React communicates with our server and our backend. So server, in this case, we've been using Express. Well, and then we've been having these two talk to each other, going back and forth. So React sends some requests to the server. On the back end, we get some things back on the front end, and then we render it as such. Sometimes, though, we need to store or access data that's more persistent. We don't want to go away, for example, if our server resets or so. Now we're going to talk about this little item over here. This is not the poop emoji. This is a server.
I muted, but it totally looks emoji.
This is a database, excuse me. So DB or database.
Are you absolutely sure?
I'm positive.
Can
I back up everything you say.
Can I interject something kind of funny?
Yes,
So,
always.
When I was doing NodeDB and I made my GitHub, I named it NodeDB because I thought that's what everyone had been saying the whole time we've been. It was actually NodeDB.
No way.
That is funny, Daniel. And that also gives us a little more insight into who Daniel is. Sharing that. I did not understand what NodeDB meant either. And then for the first couple of days at least.
I was like,
Node.
that makes sense. NodeDB. All right, cool. No, absolutely not what that was.
Actually, I thought that too, DJ.
Thank God I'm not alone in this week.
We're all alike. So we're going to be talking about today just the database portion. Get familiar with this, and then at some point afterwards, we'll learn about connecting these two, and we'll be able to have our full stack up and running. So just to go over this a little bit more, when we talk about full stack, this involves the computer, whether this computer is the client's phone, actual computer, smart fridge, toaster, whatever is going on with 5G these days, internet and everything, ways to connect appliances, the Internet of Things, so to speak. When we finish our site and put it on the internet, our computer is going to need to access the backend, their client, and then database is not something that's always necessary, but it is something that we can use as well. During our development, so far, our server has been on our computer. When you start getting to like personal projects and such and hosting those items, those servers will be on another computer elsewhere, and people will access your projects from those computers. So why do you think that it would be better to use another server somewhere else rather than on your own machine to host your site, to have people come and visit it, use it, etc.?
Other companies that are more experienced in that and hosting can guarantee more availability. If something were to ever happen on the computer next to you, or your internet were to go out, you wouldn't be able to access the site anymore, and like that.
Cool, thanks.
One word, security.
Okay, you mind giving maybe a sentence or two on that?
Well, if the database and everything in the front end and back end and your database are all on the same computer, when somebody is on your front end, they could find a way to reach out to your database, so to speak. So we all know that ethics is not a strong point for some people. So some people might reach around and touch your database, which is not supposed to be seen by the public, I guess.
For sure. Very valid point, security. So with that, I think we hit on like separation of concerns as well too. So if your computer is running your server, people do run their own servers, and that's fine as well. But typically, you wouldn't have it. It would maybe like a dedicated machine. That one computer goes down, you just lost your site. If we use like a third-party company, and we're using DigitalOcean, and we can talk more about hosting later on as well. But they have security down for hosting, and they also have a lot of great tools to go along with that. They specialize in hosting, so it gives us more options. I can't think of the economic term for that, but someone specializes in something, and you specialize in something else. You let them focus on that. You focus on your thing, and then you all share like benefits.
I think it's called a niche.
It is a niche, but it's not the economic term I'm thinking of. It's like relative something. I don't expect anyone to know it. I don't even know it. Took one class in college on that. Why do you think we might need a database? Why? So someone that hasn't answered yet, and if I don't get a volunteer, I'm going to call on someone. Why do we need a database? So what do we use a database for? And I'm going to go with Jeremy smiling.
I would say to store information for our website.
Okay, for sure. So, like in our NodeDB style, I don't think we want to store our permanent persistent data on our server itself. So let's kind of talk about that for a second. One frustrating thing that you may have encountered with a NodeDB is that every time you restart your server, you lost any non-hard-coded data. Who saw that happen in their NodeDB? Anything that wasn't hard-coded, you added some things to an arrays, you tested it out, but then your server restarted, things disappeared, right?
Yep.
Yeah, so that's not a persistent solution right there. Any hard-coded data that we want to store, should be stored in the database, and we can connect to that. And the database is going to run independently of our servers, so servers do not rely on the database and vice versa. When we turn off our servers or restart servers and install a server update that goes faulty or that goes correct and things get refreshed, our database isn't going to restart. Databases can have backups, so if something fails with the database, there's a copy of that somewhere else. There's literally databases floating around the world, on the ocean, on cargo ships, where people are just storing information, moving that around the world. It's a crazy business. And when it comes to this type of data, this databases are a perfect solution for the information that we want to store long-term or permanently. Okay, so some info that we might want to store in a database. Let's think about when we're creating and I'm going to keep going back to the NodeDB since that's still fresh in our mind. When you're building out your components, and you store information, there's certain types of thoughts that go in your head of, do I need to store this in state? Do I need to store this information, this input in a parent, and pass this around to other components? So we have this thought process. We need to decide where we're going to store data. I think it's important to think about not only the length of time that you need to store the data, but also what other parts of our website need access to that data. That determines how we lay out our sites. Before the NodeDB started, we stressed the importance of planning. These are all things that go into the planning of that, because if you start just building a house without knowing what you need the house for, you build a 10-room house with one bathroom, you're not going to have happy occupants, for example. So on an e-commerce site, thinking about the database side of it, we're planning out in our heads right now how we'll set this up. What kind of information maybe we want to store in a database for an e-commerce site, and maybe someone that has spoke up again.
Maybe like the price of the product and some images of the product.
Cool. So products, images, and price. What else? So an e-commerce site, something like Amazon, can be huge.
Maybe like a description. Okay, that too.
App customer information, so usernames and such. You wouldn't store that in a this.state location when they register. As soon as they click off that component, it's like they didn't register, right? You want to store it somewhere more persistent. How about product reviews, comments on products. It can get very complex, just whatever it needs to be for your site. So what are some items that we wouldn't care about being persistent long-term for an e-commerce site? So think about the functionality of an e-commerce site. People are clicking around looking at products and such.
Parts.
Yeah, transactions. We don't want those to stick around.
Okay, so carts for sure. Carts, the cart is my like go-to for that. So that would be kind of ridiculous to store long-term, unless for whatever reason you needed that, then that would be okay. But carts are usually very temporary. Maybe something like a cookie would be better to hold a cart. Transaction history, I might store like what the user bought. I can go and look at my previous orders in Amazon, and I know that's being stored. But certain data, part of that transaction, I wouldn't store. So correct answers all around. Social media sites, I'm allowing the user to like type in a new status. I'm not going to hold that input in a database. I might hold the actual status in a database, but not the actual input. Like to hold the input field's input. So I'd move it around once they confirm that they want that to be the actual status. So many examples here. So the whole point is that we would use a database, and database is a perfect solution to store the data that we want to be persistent. I'm going to keep using that keyword persistent. PostgreSQL is how we are going to interact with that data. It will be our tool for interacting with the data. People that have watched pre-class videos or have previous knowledge on PostgreSQL, just real quick, give me a 5-word or less definition of PostgreSQL.
An interface to store, retrieve, and work with data.
Where do I start counting on that?
It's not something you can really fit. You could say it's a data mint. Really wanted to get that simple.
Yeah, so depending on how we're looking at it, a few definitions will apply. I'm specifically focused on it just being a querying language. Some of you may have heard of SQL before. Again, PostgreSQL is very similar since it is a flavor of that. In a second here, we'll go into some examples, and I'll get this database off your screens. You can consider PostgreSQL as either a flavor or a dialect of SQL. It's almost the exact same, but there are going to be some syntactic differences. So syntax is kind of like the language that we use to interact with one of our tools. So it expects the commands to come in a certain way, and we expect to receive those commands back a certain way in a certain language. Some other different dialects of SQL other than Postgres would be SQLite, MS SQL, Oracle SQL, MySQL, and so on. So there's quite a few flavors of SQL. These are all very similar, these examples. So you can pretty much pick up one of those. If you're going on the job hunt, you have PostgreSQL, they're requiring experience in MSQL. Do not let that be a hindrance of you applying for that position. You have the experience in that. Not with that exact flavor, but it's just a flavor of SQL. So we choose PostgreSQL for a couple of reasons, mainly because it's more popular. It's one of the more popular flavors due to it being open source. It's highly community driven, and it's pretty performant. It's quick. It helps to maintain our data integrity. So it's a solid technology, and it's free. The free part has helped its high adoption rate as well. Okay, before we go much further, I just want to say when you're looking for answers online and you're Googling the stuff, be sure you type in PostgreSQL in your search, not just SQL, because you may get different types of answers back as far as the syntax goes. Just like you wouldn't type Java to look up JavaScript answers, you'd want to type JavaScript, for example. Let's talk about the type of database before we get into an example here that SQL is. We have A, relational databases, and B, non-relational databases. Can anyone tell me the difference?
You said between relational and non-relational?
Yeah, I'll just focus more so on the relational aspect. So SQL works with relational databases, and in effect, PostgreSQL does as well. Relational databases are going to contain tables, and our tables are also going to be known as relations. So whenever you hear someone talk about relations in your database or tables, it's referring to the same thing. Relational database, meaning that those tables are somehow linked to one another. We'll see what that looks like. But these tables, think about Excel or Bruce Mac's version of Excel. So Google has Sheets. What do y'all use on Mac for Excel, for spreadsheets?
Google, or you can use Excel too. I don't know.
So think of making like a table, and like in a spreadsheet program, you have a column, and then those columns can have rows. And then those rows contain data, whether it be unique data or not, is dependent upon what kind of information that you're storing there. In our tables here for PostgreSQL, it's very important that our columns contain one row that includes a unique ID. For any row that's entered into the tables, each row will need to have its own unique information, and we call that its primary key. We'll see what that looks like. Okay, so I want everyone to go to the site with me here. I'm going to put this in the chat here, the GoToMeeting chat, so look up there for a second. If it will paste. Oh no, copy. Yes, guys, it's coming. All right, I'm going to type this out by hand. Yes. Have y'all clicked that link yet? If you haven't, why not? Come on, let's go. Let's get with it, guys. The people that haven't typed earlier, I assume that you're already on the site, so good job. All right. Raise your hand if that did not pull this site up. So this is devmtn's little sandbox for working with Postgres. This is a very cool tool. So as I'm working on my projects and building out my apps, I need to go and test out some things in a sandbox with some data that's already available to me. I'll pull this up. I have this bookmarked. I'll go test out my queries, see if I'm getting the right kind of information back that I'm expecting. And then I know that that query is going to do this type of operation. So then I'll typically go and implement that into my program somehow. So bookmark this, 1, for getting some PostgreSQL practice on your queries. And then 2, you can use it as a tool, as like a scratch pad. I want to explain what we're looking at here. So when I talked about having a database with tables, if I can zoom, the way that our tables are set up, the actual structure of those tables, like what kind of tables we have, what rows and what columns we have for each table, and what data type can be inputted for those columns, that the overall term for that setup, that structure, is schema. So whenever we talk about having database schema, we're talking about the types of tables, the columns in those tables, not the rows, because the rows are going to be added in later, but also the data type that can be inputted for those tables, for those columns. So we look on the left here, schema browser. What do you think we're looking at? What is all this?
The data already in the database?
Yeah. So more specifically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 tables. Album is a table, artist is a table, customer is a table, and so on and so forth. Under customer here, I've got address, city, state, country, and so on. What do you think this represents?
The customer within the object.
What part of the table? So are these like mini tables?
Column? I would
Yeah.
assume so. Yeah.
Columns. Yeah, so customer, just imagine like an overarching table called customer, and in that customer table we have a column for address, city, state, country, and so on. And then what do you think on the right here of address varchar is, or on the right of support rep ID integer is?
It's the data type.
Yeah, so when we're working in JavaScript and we have a fave num, we expect that to be a number, so we go work with that and we use number methods on it, and so on and so forth. String, same way. Well, when we're setting up our tables, the information that gets added to our tables, we need to expect a certain type of data as well. Why is the data consistently important? Why is data consistency important? Why is it important that we define the type of data that we're working with? Anyway.
That way data isn't getting misconstrued with other data.
Yes, for sure. So that also, we'll be pulling this information and using it in our app as well, right? So we don't just store it here and then we push it all away. These databases are interactive. So in our servers or on our servers, we'll have code that works with this data, and we need to know what type of data what data type we're working with in order to not have those bugs pop up. This code is not going to be a valid code, but I want to just kind of show you the basic syntax setup for creating a new table here. So we'll be working with our stock tables over here. If I add any new columns or any new tables, if I refresh this page, it's a new database. It's the same database, but all of our custom info is going to be deleted. So this data is not persistent.
Create table name, where the columns are the name of the column, the data type,
Something like this.
whether it's null or not, and any constraints, separated by commas, and the statement needs to end with a semicolon.
Both are valid code. It's conventional to have all uppercase the actual Postgres commands, so we can see those commands separate from the information that we're actually putting into the table. So create, notice we get some beautiful color changes here as well, so we get some feedback. Create table. So this is a Postgres command. I'm not creating a table called table. So it's going to expect something after this, and in this case it would be, I'm going to put it in caret symbols here. So this would be our custom data. So this would be our table name, and then open parenthesis, and be either here or down here, doesn't matter. With an open parenthesis, you can imagine that somewhere below there should be a closed parenthesis. I know we're used to working with JavaScript. This is not a function. Don't think of this as JavaScript. This is just syntax for Postgres. So this is not a function called table. So in these parentheses, we're expecting a few items here. One would be a column name. After that would be, and notice there's a space here, would be the data type for that column. And then we'll get into constraints later, but there are any constraints to be added as well. We would include those here. Now I'll put a ... because we can have multiple constraints. That would be one column. We have multiple columns. We're going to copy this. We would just stack those on top of each other. And I believe we need a comma here. We'll find out here in just a minute. Column name, data type, and constraint. So for each column in our table, we would do this. Questions about what this looks like. Realizing also that we'll dive into this a little bit deeper here in a second.
Hey, Eric, with PostgreSQL, you're required to have
Yes.
at least
So that's a very good point. So it's often in your code you'll have multiple statements run. PostgreSQL is not as forgiving with excluding of semicolons. You need to have a semicolon in there. I can get away with this right now because this is my only statement. But if, for example, I have my create table here and then I start adding things to that table here and then I just run it all at once, PostgreSQL will expect a semicolon or I'll get an error message.
just keeping that in mind because I use a lot of command line. Some of the command line tools require you to put a semicolon.
Yeah, Jor makes a very good point with that. Thank you. Any other questions? All right, so I'm going to harp on this for a second and just break it down a little bit more. So create table, what this is doing should be self-explanatory, I think. You're telling PostgreSQL to create a new table. table name, let's say that I have a table and I'm going to call it user options. So there are conventions everywhere in coding. For PostgreSQL for table names, it's convention to have our table names in snake case. So for example, user underscore option would be a good table name for that. And I'm going to actually put that back there. Commenting out in Postgres looks like this. Use a dash dash space whatever or dash dash whatever. It's fine. So we do have a way to comment out code and add information, a description to what our queries do. This being a create table query. So for our user options, I had create table user options. Parentheses here, semicolon. Okay, and inside the parentheses, again, we are specifying the names of the columns, and we can add multiple columns at one time. So let's say that with my user options, I had a column. I would call it. Let's say that we had a column for dark mode. So in our app for dark mode. In our app, we let users have a dark mode option in the website. And that would be one value for light and one value for dark. So that column I would call dark mode. And then thinking of JavaScript, feel free to shout it out too. What would be a good data type to use for dark mode? If all it does is store whether or not they want to use dark mode or not.
A Boolean?
I'd probably go with a Boolean on this. So we're not inserting information into our Postgres table right now. We're setting up its structure. So we have a type called Boolean or bool. Notice how that turns blue? Or Boolean works as well. Daniel.
I typed it in lowercase and it still turned blue. Does it matter if it's uppercase or lowercase?
It doesn't. Again, that's just convention for making it more easily readable to us as a developer that that's an actual command, and then the lowercase is our actual custom data.
Makes sense.
Cool. And I think bool will work. Yeah, lowercase bool works as well. Yep. So we have dark mode Boolean, so that would accept true or false, like what you're used to. I'm going to try to make an example here for this table that uses the more popular data types. Let's say that since this is user options, we have a fave num. So for whatever reason, we're using their favorite number. So fave num, what would be a good data type for fave num?
Integer?
Yeah, let's go with integer. So int, int, what is that? I'm going to make that uppercase again. So int or integer will work for that. If we want to allow them to create a decimal number, say fave decimal, we could use something like float. If we want to be specific, we'll allow decimal spots in our number. I could also use, as another example, fave decimal 2, I believe. Yeah, decimal is a data type. We can use that. Let's have in our table something called fave word. What data type should word be? In JavaScript, we would use 10.
JavaScript will be string, but I think for this guy, SQL is like varchar.
Yeah, so we'll get into varchar too. We'll have a couple of favorite words here, so we can show both of those. So fave word, I could use type text, and instead of using something like string in JavaScript, we use text here. And to go into Chen's answer, fave word 2, let's say that I wanted them to have a limited amount of characters for this word. So yeah, any text would be fine. Daniel, okay.
All right, just got excited.
Oh, very cool. I love it. So you can have a fave word. So let's call this fave short word. And on the front end, before it gets to the tables back here, before we store it, we say, please enter your favorite short word. Must be shorter, must be 5 characters or less. Something such as that. So on that type, as Chen was going, what Chen was talking about, we would use varchar or varchar parentheses. And these parentheses require a number inside. And in this case, if we're limiting it to 5 characters, we'll put in the number 5. Anyone know what varchar stands for? Chen, I'll go with your answer first since you brought it up. What does varchar stand for?
I think it's variable character.
So varying character, and then varying as in we can input any number of characters as we like, or we can set the limit on that. Excuse me.
Yeah, so the 5 I think is maximum 5 letters, 5 characters.
Yeah, and you'll see this in your code if you don't have that check on the front end to see how many characters they are. So as a full stack developer, you've created your database, you've set up the schema, you've set up the structure, you know what it looks like, you know the data types it takes, you know what to expect in there, you know what should or should not be null or what should be empty. When you're setting that up on the front end, code in some of those checks there. If they have that input, maybe limit how many characters they can have in that input. If for some reason on the front end you let them submit 20 characters and then you try to run this command that allows only 5 characters in this column, you get an error back. Either some or none of your data will get pushed into that table. That's not what you want. Okay. Let's say that we have something called nothing. I'll just call it empty spot. So we also have a data type here called null. What is null in JavaScript? Let's go with Pemba.
I think it means nothing.
Yeah. So it's like nothing. There's nothing here. Nothing here yet. We expect something possibly in the future, but there's nothing yet. This is a placeholder for nothing. Just think of null like that. It's being defined, but it's being defined with a placeholder saying that we expect something, but there's nothing now. It's null. Okay. So lastly, yes.
Yeah. So in the real world, like in companies, does somebody like manually create tables, or how does that work?
Anyone want to answer that with your experience? experience, because I know we all come in here with different backgrounds. So in a larger company, let's say something like Microsoft or Google or even something else like Chase Bank or whatever, you'll have people that are typically just dedicated to the database itself. The database administrators got different roles within all of that. They're on the database side. That's what they do. They work with database. They'll have other departments there that for people that work on the front end, maybe another department there that works on the back end. So the larger the company, the more that they can split up the specialization of these roles. So yeah, you would have someone somewhere creating these tables as necessary, changing them up, and so on. Now, if you were to, let's say, go into a startup right after Dev Mountain, you may be the unicorn, so to speak. And if you haven't heard that term, is you're a gopher. You're the person that they go to whenever they need something done. Database side, front end, back end. You're like the general manager of all of that stuff. So smaller the company, the more ponds you'll be dipping your foot into, whether that pond is the database or the back end or the front end. But the bigger the company, the more you're able to actually specialize. So someone somewhere is going to be putting this all together at some point. Okay, I did talk.
Sorry, I have a question regarding varchar. So, like, say if we want to have a field where the user can put in a password, and I know sometimes in those areas there's text input, they want you to have maybe more than 8 characters, and they won't let you submit it unless you have 8 characters. So so I know how like we put varchar and then we put 5, so that's the max amount of characters they can have. Is there a way you can set it to a minimum, or maybe even like a range from 5 to 16 characters?
So I think the best way to do that would be to have that check on the front end. So sometimes when you type in a password and you tab off the field onto the next field, you'll get that little red asterisk saying password does not meet requirements or so on and so forth. Think of that as a check if that's a React component, that might be a function that's running in that component, like check pass or something like that. So that's where you'd want to do that check before it even gets to the back.
Okay, cool.
Sweet. Last thing before we go on break here, I mentioned that every table needs to have a unique ID. So I have a student. So let's say that we have a student's table. So we have a student table. We get the Postgres thinking here. So let's say we have a student table and we have a column for name and only name. So for whatever reason, we just hold the name of the student. We're very privacy centric here. We don't need to know your age or if you paid or anything else. We just want to know your name. Much like the real world, I'm not the only Eric. Might be the best Eric, but I'm not the only Eric. There's also more Daniels. We have the best Daniel, multiple Melissas out there, and so on and so forth. So there might be a student, and in this table, we have under name, Eric, and then we have another Eric, and then we have another Eric with a K. And then we have Daniel, and we have a Melissa, and we have a Melissa with the same spelling, and we have a Melissa with an A and one S for whatever reason, and so on and so forth. In our tables, we need to have something that's unique for each of these entries. So it's important that each of these has their own unique ID. So whether that be a number that we set, and so on and so forth, there is something unique to this row, and that is this row's ID. This Eric has a different ID than this Eric. This Melissa, a different ID than this Melissa. So when we create our tables, there's also convention for whatever your table name is, have the ID be called the table name. So user options, and then add ID to the end of that, append ID, and we'll talk about that data type here in just a second. Let's go on a break. We'll come back. We'll continue with here. Let's come back at 11:40.
Cool.
So please be ready to go at 11:40.